Thank you very much, Zach. My name is Mike Jacob, one of the co-founders of Kiss House. Great to see everybody here today. Really looking forward to this very personal looking presentation. I had a sneak preview of the film that we're about to see a couple of days ago. And what's great is we're going to get an insight into, the guts of a building that may never have been seen had it have been in the hands of, I say, a less conscientious owner. And we get to see as his kids involved in the project and the mountains emerging and all sorts of wonderful things. I'm really looking forward to it. So yeah, thanks very much. Over to you, Hugh.
Yeah, cheers, Mike. I'm Hugh Wirsky, director at Partel, and pretty much, Mike, I was going to say the same thing as you. Yeah, I followed a little bit of Es's journey on Twitter, so really looking forward to getting into the detail on that. But yeah, like you say, some of those images are they're going to be good for everyone to see, and maybe it will encourage people to take that look deeper into what's behind those walls that they can't see. Yeah, so Ben, over to you.
And there's also the story element of this that it's quite a journey, as I'm sure we'll unpack as we go through this. So I'm going to do the introduction here. After getting a degree in ecology, Es Tresidder's journey to low energy buildings incorporated time working in an earthship and teaching children in schools about recycling. There then followed an MSc at CAT, the Centre for Alternative Technology, and a PhD in optimization of low energy building design at De Montfort University. Initially skeptical about Passivhaus, his interest grew upon interacting with the wonderful world of Twitter, the Passivhaus community on there. He then completed the Passivhaus designer course, which he credits with teaching him more about building physics in 2 weeks than he learnt about in the entire duration of his MSc and PhD. Es ran his own consultancy, Highland Passive, for a few years before moving to work full-time as a Passivhaus specialist for John Gilbert Architects, probably one of the top sustainable architecture firms in Scotland. He's in the final stages. He's moved back in of retrofitting his home. There are a couple of things we haven't shown, that room full of bags and everything that he's unpacking. But this is in Fort William in Scotland. We're now going to take a look at his video.
This is a nearly completed EnerPHit of a 1975 timber frame house on the west coast of Scotland. We had been living here for 5 or 6 years before we decided to start the retrofit, and the motivation for that was on multiple fronts really. The house was too cold, it had damp and mould problems in places, it was expensive to heat, but also upstairs the space was really poorly laid out. It's what's called a 1.5 story house, which is very typical for around here, where the slope of the roof comes down to meet the ceiling of the ground floor. And so the floor area available upstairs is quite dramatically reduced compared to the full footprint of the house. The retrofit that we did was very radical in many ways, but addressed that. We did think about whether we should sell the house and build new elsewhere or knock the house down and build new here. The location where we are is really great for us. It's close to schools, walking distance to schools, cycling distance to town, so we don't need to use the car much at all. It's 5 minutes walk to a train station if we're going further afield. So the location was really key for us, and that was the reason not to sell and build somewhere else really. And then the question was, do we knock down and build new, or do we retrofit? And I'm pretty sure that what we did was cheaper than knocking down and building again. But also I think I would have, from a conceptual point of view, knocking down buildings that have still got plenty of life in them feels the wrong thing to be doing in terms of carbon emissions really, and using resources wisely. So yeah, we chose to retrofit, and before we started we knew that we had a problem with damp. We would get mould in the back of cupboards and in corners and sometimes around windows, and when we stripped the house back we realised that the problem was much more extensive. We discovered quite a lot of pretty badly done work. This bit here used to be a doorway, so at some point it was filled in before me. And then the way that a timber frame works is that you want to have a ventilated cavity between the blockwork and the timber frame. They just filled this with insulation flush with the blockwork. They didn't reinstate the ventilated cavity, so that got really, really damp, and there was lots of black mould and had plants growing in it and all sorts of things. It was pretty disgusting. These are 100mm deep studs, and previously there was just about 10 or 15mm of glass wool insulation in there. I had loads of mould in it because the air is leaking into the structure and condensing and causing dampness and mould. So we're fully filling them with 100mm bats of, this is hemp and jute insulation. So fully filling it helps with the mould because there's less air in there, and mould likes to have a bit of air. And the hemp and jute is hygroscopic, so any moisture that does form can dissipate throughout the hemp and jute, whereas something like glass wool isn't able to dissipate moisture in that way. And then we're going to have another 40mm of wood fibre board inside that, and then an intelligent air tightness membrane. Most of the time that acts as a vapour barrier, so it stops moisture from the room getting into the wall build-up. But in very sunny weather you can get something called reverse diffusion, where the sun is shining on the wall outside and it drives moisture from the outside of the wall through to the inside. And because I've not been in control about what the sheathing board was on the outside, because that's pre-existing, I want the wall to be able to dry out in both directions. So I'm trying to make a wall that is very moisture robust. So I'm using hygroscopic and vapour open insulation, and then I'm using a vapour barrier that is variable so that it can dry out in both directions. So this is the living room, and we've got two big changes we're making here. When you're sat in a sofa over at the other side of the room, the view of Ben Nevis is split by this mullion, which always seems a shame to me, so we're going to replace it with a single piece of glass. Make it a bit higher off the ground to reduce solar gains in the summer, to reduce the overheating problem, because this room already overheats a bit on sunny days. So that will help a little bit with that. We're also going to be putting another window in over there, where you can see there was a window before. I don't know why they took it out. We're going to be putting an opening window in there, so that'll even the light out a bit in the room nicely, and will enable us to cool the room when it gets too hot, because with this sliding door we found that you didn't really want to leave a whole sliding door open, so it would just get really hot in here in summer some days. Lots of what I did early on, well, everything that I did early on was DIY by me, and I always wanted to stay doing the insulation and the air tightness and the MVHR installation, partly as a kind of professional upskilling for myself, and partly just because I think those are the areas that the existing building trade is generally lacking lots of experience in, and I wanted to make sure that it was done really well. But I always knew that the bigger things that we were going to be doing in terms of taking the roof off and rebuilding that first floor, I was never going to do those as a DIY job. So we employed a local joinery contractors who were interested in doing Passivhaus and had some existing experience on it, and we're keen to continue learning there.
Generally, clients doing part of the contract for us is a bit of a no-no, basically because it can complicate the contract sometimes, and also, your client-contractor relationship can get a little bit frayed if you're not moving in the same direction. But due to Es's background and experience with Passivhaus and EnerPHit, we knew that having Es would probably be more of a benefit to us than a drawback. So it was quite an easy decision on this project to let Es come on with us and work together. The main job for us was to take the roof off. The actual roof design itself was quite complicated, engineer and architect drawings for it, and there was a lot of back and forth, shall we say, between us and the engineers, because some of the details were really complicated and there had to be a little bit of negotiation about how to go about them, because sometimes it's easier to draw it on paper than it is to do it in real life, and there was compromises made on both sides in the end, but we all got what we wanted to get the roof. Like, as I said, that was the main challenge, and the second challenge was the air tightness layer. So the air tightness board on the inside of the I-joist, putting the boards on and, you know, trying to have no gaps, trying to make sure the joints are taped around the windows. That was a real big part of making the project what it needed to be, because if you get these details wrong, the house would never have hit the target that we needed it to hit.
It was challenging at times for both of us because I was never able to work fast enough to keep up with them. I was working in the evenings and at weekends. I was having to upskill myself, and you know, they were a team of between 2 and 8 guys who were working full time and obviously had most of the skills that they needed already, or all the skills they needed already. There were several points where things happened too quickly and we didn't do an interim air pressure test, because to make that worthwhile you need to have the air barrier visible so that you can find leaks and fix them before the air barrier gets covered over. But by the time the builders were wanting to put the plasterboard up, I hadn't finished the air barrier in some places of the house, so there was no point in doing a pressure test at that point. And you know, that's totally understandable. From their point of view, they want to go as quickly as possible, which, well, it's kind of what I wanted as well, because we wanted to be out of the house as short a time as possible. But it meant that that interim test that is usually very important wasn't done, and so I kind of just had to do as good a job on the air tightness as I could and hope that it had been good enough. And we've just had the final air pressure test and we got a really good result for that. Yeah, I guess a way around that would have been for me to project manage the whole thing and to employ different trades at different points in the process. I think that would have been more stressful than what we did. I think it was quite helpful having Steve project manage everything, and certainly quicker.
It's probably taken up a lot of our sort of management time on it to pull it through to the finish line. But I think in the long term, what we'll take away from it as a company, and you know, what we've learned from it, it wouldn't frighten us, you know, taking one on again. And if we did go to do something like this again, we'd be a lot more efficient than we were this time. So if you look at the company and you look at our margins, we'd be more effective and more efficient at delivering the same thing.
The most annoying thing has been my dad being busy, but it's been interesting seeing like what there is behind the walls of a house and helping.
So I helped lift up the floorboards and put the insulation in there.
I helped quite a bit with the air tightness and stuff.
It's a lot better. It's more comfortable and a lot warmer.
Partly it's because it's quite a bit bigger and I have my own room, and also it's just a lot warmer and nicer to live in, and got windows in better places, and yeah, it's just nicer in almost every way.
The first week we moved in was pretty cold. It was like nearly freezing overnight, and then I think maybe getting up to a high of 6 degrees in the day. So the heating was on then, and that was a really good test of this really simple heating system that we've gone for, of just a single air-to-air heat pump in the dining room, and that's heating the whole house. Because our space heating is from an air-to-air heat pump, we need a separate way of heating our hot water, and this is a dedicated heat pump water heater. So it has a small heat pump that sits here that takes heat from the air. So you've got an inlet here and an outlet here that I've just stuck that on to stop recirculating too much. And you can either duct that to outside, duct both of these to outside, or it can take the heat from the room. So I've set it up to take the heat from the room for various reasons. And that seems to be working really well. So it's just a small heat pump that sits on top of a 200 litre hot water tank in this case. Obviously it's only a month of being in it, but I'm really encouraged by how it works thermally. Loads of things that I knew about as a Passivhaus designer, but are still quite surprising, like taking a shower and then hanging a towel up. I took a shower one evening at like 11 PM at night, and the next morning my towel was bone dry, and there's no radiator in there, no heated towel rail. It's just you know, in a 20-degree room with good ventilation, and that dries things out really quickly. So yeah, super comfortable to live in. Even when it's cold, we're walking around with just one jumper on, one sweater on. If you're a bit more active, you go down to a t-shirt. If you're a bit less active, you put your sweater back on. It's super, super nice. What we did here was really, really radical, and I still need to really sit down and think about whether it was the right thing to do. I mean, it's resulted in an amazing place to live, and so I'm not going to regret it, but it was really radical to take the roof off and take the first floor down. If all we'd done was retrofit the existing structure, it would have been a lot simpler and a lot cheaper. And I'm kind of hopeful and optimistic about the scope for there being like a DIY approach for these timber frame houses, which are almost ubiquitous in this part of the world. Like it's how all the houses are built and have been since the 80s really. And this type of housing lends itself to a DIY approach with some expert input. I think the expert input is really important because there's quite a few places you could go badly wrong. And they're kind of specific to each project, but I think there is real scope for having like a DIY-led approach.
Okay. So I'm just going to go through a bit more detail of the kind of key details of what we did on the house in terms of the fabric of the building, and if people are interested in other aspects, then they can bring that up in the Q&A. But this is just a quick presentation, so I thought I'd focus on the fabric of the house and primarily looking at the retrofit bits of the house rather than focusing a lot on what we did upstairs, which was essentially a new build. So yeah, we started with this house at the top, 1.5 story house, 2 small windows facing funny directions when there was an amazing view to the south, and the windows in the bedrooms upstairs, one of them had a view to the south, the one that you can see there at the top. The 2 bigger bedrooms had a view. One had a view of the neighbour's wall, and a trickle vent directly above their oil boiler flue, and the other bedroom had a view of a tree a few meters away, when there's this amazing view of the mountains just to the south. So we were keen to get more space, and we were keen to get better views and better light in each bedroom. So I'm just going to talk through the details from the ground up, really. So we had a suspended floor with no insulation in it at all. And I mentioned that we didn't do an interim air test, but we did actually do an air test before we started on the project. And it was very interesting when we depressurized the house, all the carpets on the ground floor lifted. There was basically just air leaking through the floor everywhere. And so that's a really big impact on comfort, both in terms of drafts and in terms of walking around on a surface that's cold all the time, probably even in the middle of summer, it'll still be cold. So we insulated between the joists. The joists were 180 mil deep, and at the time in PHPP 9, in order to meet the EnerPHit component criteria, you have to hit a U value of 0.15 or less for each of the elements. So for the ground floor, I needed to add more insulation underneath the joists. And what you see here was my first or one of the early iterations of what I thought I would do, which was to add a block of wood fiber insulation underneath each joist. And actually, I simplified it from this. I extended the joist with a bit of 9 mil ply, and I suspended a breather membrane between those joist extensions, and then I filled that with loose fill wood fiber insulation, the sort of wood fiber insulation that you normally blow into walls with a big machine. But I was mixing it with a drill with a big kind of paint mixer thing on the end, and then putting it into the floor directly like that, and that worked very well. So this is with the floor. This is what we were starting with. It was dry. It was, once all the rubbish had been taken out of it, it was pretty clean. So we didn't have a kind of existing damp problem in the floor, which was a relief. The subfloor had like a bituminous covering, so there's pretty low moisture input from the ground in this situation, which is good. So you can see here I'm extending the joists with the 9 mil ply, and then suspending a breathable membrane and that's does several things. It holds the insulation in place, but it's also windproof, so that when you've got air movement in the solum, in the space underneath the floor, that's not getting into the insulation and reducing the effectiveness of the insulation through wind washing. It's really critical that that's vapor permeable, so that the water vapor moving through the structure can escape into the solum, and the solum is ventilated, so the moisture can then get out of there. I think with the floor, this is one bit where I would really think carefully about how I'd do this again if I did it again. Extending the joists like this was really labor intensive, and I don't think I would do it like this. I'm not sure exactly how I would do it. I've got several ideas of how I would do it, and if I get another project like this, I'll sit down and work out which one's best. But doing it this way was a lot of work for an extra 100 mil of insulation, was how it felt. And I actually had to do this. I'd put all the insulation in, and then I had to take it all out again because it all got soaked when we took the roof off. But that's another story for another day, maybe. So we were filling it with this loose fill wood fiber that you can see in the top of the picture there. We didn't take the stair up, and that gave us a bit of an air tightness headache. Like, how do you make it airtight underneath where the stair is landing? Maybe we should have just taken the stair up, but at that point in my retrofit journey, I was still very wary of taking on big bits of DIY. I was still pretty fearful of those, and taking the stair out just seemed terrifying to me, so I didn't do that. And so I'll show you in a minute how we did the air tightness there. So yeah, filling the void with this, filling the spaces that I'd created between the joists with this loose fill wood fiber. That was really good because we had complex spaces to fill. It was really good at being able to fill all the spaces with no air gaps. But it was quite a lot of work to get in. And it's compared to other natural insulations, it's very cheap. So it's kind of swings and roundabouts. It was a lot of work. It was very effective, but it was really cheap. So it was very cheap and very effective, but it was a lot of work. So yeah, swings and roundabouts. This was the method we used for ensuring airtightness under the stairs, was to send a keen small child into the solum, and he did a really good job. It was actually his idea to go down. I'd like to emphasize that I wasn't encouraging him at all. I couldn't fit in there. He could just, and yeah, so we put him down there for 20 minutes to tape the airtightness membrane into place. And that worked really well. We had a good result from our airtightness test a couple of weeks ago, so that was reassuring. Then this is the ground floor walls. So the existing studs were 100 mil deep, and then they just had plasterboard straight on top of that. So I was removing the plasterboard and then filling the studs with 100 mil of hemp and jute insulation, and then the pink board on top of the studs there, inside the studs that you can see there, was another sheathing board. The structural engineer wanted us to increase the strength of the ground floor walls by and also tie in the new studs that we were putting in around windows to ensure that it was strong enough to take the extra load that we were adding upstairs. So there's another sheathing board, and then 40 mil of wood fiber board insulation, and then an air tightness intelligent membrane, and then a 40 mil service cavity that in this picture is insulated, and we actually didn't insulate it. That just struck me as being quite a pain and quite a lot of I think the electrician and the plumbers would have been quite hostile to me filling it with insulation. So I went for the easy life there, and I think I probably would keep it that way. I think service cavities are best left unfilled, and yeah, that's what we did. In terms of kind of throughout this process, I was always often thinking, like, if I did a shallow retrofit rather than deep retrofit, what would we have done? And I think what most builders locally would have done, if you said you wanted to insulate a house like this, is they would have just come in and put in insulated plasterboard on top of the plasterboard that was there already. And I'll just show you what I think that would have meant. So this is what we had already. This is what we would have been putting insulated plasterboard on top of. And given that you're not really doing very much about air tightness, and you're making the existing wall colder because you're adding insulation inside of that, I think this mold problem would get even worse if you'd just done that. So I think that's fairly grim. So what was going on here, the left picture is a mix of rotten, of moldy insulation and rodent feces and rodent skeletons and all sorts of horrible things. And then the other two are just, bog standard mold. Interestingly, the worst black mold in that central photo is where the socket is, so that the air is leaking around the socket. The socket gives a path through the plasterboard, so more air is leaking through there, bringing in warm, moisture-laden air into that space, which then cools, and the humidity goes high enough that you get mold. Just going back to this, the other thing that I was thinking as I was doing it was, if all I did was this, if I wasn't adding, for example, was it worth adding the 40 mil of insulation board? Well, you've got more thermal bridging through the studs, but also, are you able to see my mouse actually? Yes, okay. Also, what was drawn here, this was drawn before we took the walls apart. And actually the studs there was one stud like this, and then this stud wasn't here, it was here. So if all I had done was insulated between the studs, then there would have been a space here where it would have been impossible to get any insulation. And I would have had a cold corner that is already a geometric thermal bridge, and it's a corner, so there's less air flow around it. And I think you'd just end up with a load of mold internally if I'd done that. Or that would be the risk. Maybe it'd be all right with MVHR, but that would certainly be the risk, I think. So this was filling the walls with the hemp and jute bats. These come conveniently sized to fit either 600 mil center studs or 400 mil center studs. My house was like sometimes 400, sometimes 420, sometimes 360. It was all over the place, so I was having to cut them quite a lot. If you have to cut natural insulation, get an insulation saw. I tried all sorts of saws before finally spending £30 or whatever on an insulation saw, and wished I'd done it earlier. Lots of studs that were kind of a little bit apart, and you had to kind of poke insulation into them to make sure that there weren't any gaps in the wall build-up. And all of this, like you can see there, there's 3 studs right next to each other and another stud right there. And if we hadn't been adding the wood fiber insulation inside of that, I don't think it would have been a moisture risk problem, because the wood is okay, but you would have ended up with certainly a surface that was colder than the rest of the wall. So this is finishing the wall off. So this is the wood fiber, the sheathing board that we added internally. So behind that is the existing 100 mil studs with the hemp and jute. And then to the left of that, we've got the 40 mil of wood fiber board that we added on. And then the membranes are going up. And you can see that everything's happening in funny orders. They're already trying to, the timber at the bottom is them strapping the walls for the plasterboard. So I was rushing around trying to keep up. And then window reveals. Some of this was worked out beforehand. Some of it was working out on site. I had bits of 20 mil insulation left over that I was able to cut to fit exactly into the window reveals, and that gave a good edge for bringing the membrane round and then taping it to the windows. If I did windows again, I think I would tape them before they went in. I'd use split release tape, which I did use, and I'd tape them to the window frame and then put them in, and then have the second release tape to use separately. The way I did it was effective, but it was quite fiddly, and there are a few places where you can just see a little bit of tape internally. And then upstairs we did an I-joist frame effectively, and there are a few bits that we could have done better there that are more relevant to new build, but I think are easily missed. So here we've got a junction that you can't access this point here from inside. So for blowing the insulation in, you blow for these spaces, you blow them in from the inside. But this space, you have to go out on the scaffolding and blow it in from the outside, which is annoying if it's raining. And it's often raining in this part of the world. So make sure that your stud arrangement at the corners, it gives you a path, so that you maybe have one of these offset down here somewhere. You need to clear it with your structural engineer so that you've got a path into this space for the blown in insulation. This is the junction between the ground floor and the first floor. So this was a bit of a structural engineering headache for the structural engineer. And effectively we built like a ladder here, and that enabled us to build a solid platform that we could then build the first floor walls off. So it's not weighting this, it's not loading this this blockwork wall. It's all of the load is through this timber frame here. So that worked well. There are a few things that I would do slightly differently, mainly with the weatherproofing of it. I think I put the insulation in, and then we tried to weatherproof it, but these joints were open, and basically the rain would come down here and then track through these joints, and this all got completely soaked, and I had to pull it out and then do it again once the walls, the other parts of the walls were finished. So I think I would try and find a better way of doing that. And yeah, this is the I-joist frame being built on top of the house. For a long time, the first couple of months, we felt like they'd done loads of work. We'd given them loads of money, and all we had was half a house. But at this point, it was starting to look like we were actually getting a bigger house again. Yeah, these again, this is probably more relevant to the new build. I didn't think carefully enough about window positioning and window sizing in terms of the I-joist layout. So the image on the left, if I'd sized my windows or positioned my windows slightly differently, I could have had fewer studs, because you've got a stud right next to the window, and if you can line that up to be at your 600 centers or whatever centers you're needing it to be, then that's a lot better than having two right next to each other. And I also had to go around and be measuring them to check whether they were wide enough to have the insulation pumped into them from inside. And if they weren't, I was having to pre-fill them. I didn't have to pre-fill, I may have only had to pre-fill one of them, but some of them were quite tricky to fill. And actually the drilling of the hole in the airtight board is quite hard and quite time consuming. So you want to limit the number of holes you have to drill. So you want to make sure that they're all spaced as well as they can be. And yeah, at the end of the process, it was like many extremely challenging things in life. It was equal parts wonderful and equal parts horrifically, traumatically stressful. But we're in now, and it's lovely. This is the sunrise on one of the first mornings we were in. So condensation on the outside of the window and looking towards a frosty Ben Nevis and Glen Nevis there. And yeah, I guess I'll just open it up for questions from there. Really, that's me. That's my presentation done.
Thank you, Ez, very much indeed. That was really inspiring. And you just touched on the trauma at the end. I could sense it throughout. Mentioned more than one layer of insulation needing to be removed due to water damage. And
yeah.
I can imagine you're probably just scratching the surface.
I mean, that was a big thing for me. Like basically a big learning point for me was just how hard it is to keep water out of buildings when they're not finished. And because basically all my experience is computer based until this, so it was a really steep learning curve. And we were offered at the start of the project to tent the whole thing, but that in itself was really expensive. I think we were quoted more than £30,000 for tenting it, and so we decided not to. And that meant that we had to redo the insulation in the ground floor, all of it, and we had to redo the insulation around that perimeter that I showed you.
Yeah.
So I think I would do those in a different order, but I don't think I would tent it, just because 30 grand is a lot of money for something that you just need to change the order that you do things in so that they can dry out.
the thing that really stood out to me, or that at least that I kept thinking about, was the mold. And I'm thinking that, you know, you live in this really healthy part of the world in terms of the mountainous landscape and the fresh air, and no doubt lots of healthy outdoor activities, and yet you're living, and as are many other people who live in those sorts of houses, in an unhealthy internal environment in terms of the mold. And you said you were there for 5 years, and I just wondered if you and your family had experienced any health impacts from that mold in the period of time that you were living there up until you carried out the refurb.
It's hard to tell because we didn't have asthma, we didn't have rhinitis or anything like that that's, you know, really known to be caused by mold. So not necessarily, but it might have had a more subtle impact on our health than that. I think that link between kind of outdoorsy people then living in unhealthy houses is really interesting, because, you know, most of my friends are outdoorsy, so we're going out, we're getting soaked, we're coming back with wet clothes. Or if you've got a dog, wet dogs as well. We haven't got a dog, but lots of people do. And I was reflecting that in Loch Arbor, which is this region, most houses have either a tumble dryer or a dehumidifier or mold, and lots of them have all three of those things. Yeah, it's really, really common to see a dehumidifier in someone's house.
Well, I commend you for doing it. It was really inspirational. Hugh, any observations from you?
Yeah, I've got a couple of comments and maybe some questions. So yeah, again, as thanks for being so open with the sharing. There's a wealth of information for people to, you know, to absorb and learn from. But the thing that kind of strikes me is what's the real lifespan of that house without your interventions? When you look at that from a structural point of view, I think it was on a path to some fairly serious issues. Probably the same with health, same with running costs. And then if we look at I suppose the 2050 emissions that we target, where there's, I think, 30 odd million homes that need to be retrofitted, it probably fits into that category. And I'm wondering then, yeah, for all of the work you did, is there grants available? Were they available? And when you talk about things like roofs and removals, it really seems like, and I see this a lot, it's an inevitable thing to have to do to upgrade that type of house, that you really can't do it well enough without doing that. That's, I suppose, a kind of a comment or a question. Is the other ones were, what were the reservations from you and your family about doing the work, and were you fully aware, I guess, of, you said everything was computer-based prior to that, yet you're obviously quite hands-on and you've done, you know, a lot of work yourself there. I'm wondering how that part worked. And last one then is, I love to see the water heater. It's really smart. It's a smart solution in a lot of different ways for your type of house. You know, even as you move to low energy nighttime costs, I guess you can use it kind of as a battery.
Yeah. So we're doing, in terms of the heat pump, the water heater, yeah, we're heating our water at night, and it's quite noisy when it's on, but it's, you know, we can't hear it from the bedroom, so that's okay. And I've got some plans for how to make it less noisy in use, so that when we get solar PV, we can run it off the solar PV during the day as well, because it does give quite a useful amount of cooling. That at night time is a bit of a waste, because you don't, at this time of year anyway, you don't really want it to cool the house at night. Whereas in the middle of the day, at this time of year, certainly on sunny days, that would be, you know, certainly fine.
Nice.
To be cool in the house. In terms of, the kind of taking it on and understanding how big a task it was, I suppose I'm like a bit of an optimist to a fault, and it was definitely more time and more work than I anticipated. So that was, that's tough in terms of the family, but they were very supportive.
Perfect.
I'm lucky to have them. And in terms of the lifespan of the house, I'm not a structural engineer, but I think you're right. Like that all of the studs were fine. There were no studs that were starting to get damp, but all of the sheathing board was damp. And that strikes me as a thing that's not great in the long-term health of the house. I actually did something else that I didn't mention, was that I realized that the cavity between the blockwork and the timber frame didn't have any deliberate ventilation. Yep. And so I think that was part of the reason that the mold was so bad. So I actually drilled a hole along the bottom of the walls, yeah, and along the top of the walls every 1.5 meters or something, and put a little vent cover in to try and ventilate that space better. So I've kind of done lots of things that I think taken together will mean that the wall's not moldy anymore. And I'm also I've got some sensors that I'm going to put in both the floor and the walls, so I can monitor what's happening there.
Yeah, really nice. Yeah, well done. Look, the problems that you've come across, they're obviously in all of the houses, built in that time. So yeah, it's amazing information.
And probably the houses that we're building now, to be honest, like that's the scary thing, is we're still building. We're still building houses like this, just with more insulation. They're still not very airtight, and they're still not ventilated properly, and they're still full of thermal bridges and missing insulation, and it's pretty depressing.
Yeah. Ben, what did you think? You've been closer to it.
Yeah, this is a project that has just been so interesting to me, both to watch on Twitter, read all the updates, and also I've done a podcast, so I know all sorts of things. Just before I go any further, I'd like to thank Mike Coe and Lizzie Stoodley, who are based, I'll say, near to Es, but that's still 4 hours away, who did the filming. So that was really good of them to head down there. Having seen quite a few retrofit projects now, I think that one of the key things is about making it somewhere that you want to live for you never know what the future holds, but a good few years. And I think that everything that you've done is to make that house a home for you for the foreseeable future. And I think that's the only way retrofit can work, because it takes so much time, it costs so much money, and it is in that balance. But what I've always loved about Es and what he's done is how honest, and occasionally he'll say, I'm not sure whether this retrofit really works, but he's always looking and analyzing and just coming to his own conclusions. But what is the alternative? As he's saying, it's difficult. You don't want to trap all that mold and just forget about it, because there probably is some unseen consequence that's going to happen. So we better hand over to Kim, though, because I know there are quite a few questions that have come in during this.
Great, thank you, Ben. All right, just a reminder for everyone, we will go through the queue, ask you to come off of mute to ask as your question. If you're unavailable to do so, please let me know in the chat ahead of time if possible, just so we can make this as efficient as possible. Starting off today, we have Elisa. You can come off mute and ask your question.
Can you hear me? Hi, hello.
Perfect. Yes.
Perfect. Thank you for the presentation. So I would like to ask if the house is mechanically ventilated. I would like to understand the ventilation strategy. And as a second question, I would like to ask if I understood that you modeled with the PHPP your house. So I was curious to understand if you customize your internal gains based on your lifestyle.
So it's got MVHR. You have to have MVHR for EnerPHit or Passivhaus in this part of the world anyway. That's been great. I installed that myself, but it was designed and commissioned by Paul Heat Recovery Scotland, who are really good. It's a Zender Q50 unit. I modeled it in PHPP. Yes, I should have mentioned that there's 2 methods that you can use to reach EnerPHit standard. There's EnerPHit energy standard, which is that you have to be below 25 kilowatt hours per meter squared per year. And there's EnerPHit component method, which if you're having to do lots of internal insulation where you can't get to such low U values, it's very difficult to get below 25 kilowatt hours per meter squared per year. So you tend to go for the component method instead. And there's a relaxation on the U values that you have to achieve for ground floor, for the walls, because if you're internally insulating, you can't get to such low U values without either a high moisture risk to the wall or losing lots of internal space. So my walls on the ground floor are about 0.26, I think, U value, whereas the first floor, they're like 0.13. So where am I going with this? So we wouldn't hit the 25 kilowatt hours. I think we were at 27 or 28. Did I customize the internal gains? No, because I can't do that for certification. I did a bit of that to test it for summer performance, but actually for here, the summer performance in this building in PHPP is 0% of the time over 25 degrees. But actually, because that averages it out over the whole house, there is one room that I think might overheat, and that's the living room with the big window. And I kind of thought that from the start. And basically, I'm just going to see how it goes. And if it does need more shading, I'll put a temporary shade up that I can take down. I can put up at the beginning of the summer and take down at the end of the summer, or some kind of trellis with trailing plants on it or something. But so far we've had, so we haven't, you'll laugh at this hot weather, but we've had like 20 degrees and very sunny some days, and the living room has got to 23 degrees. So that's fine. But it might, in the middle of summer, we do sometimes get days where it's high 20s. The sun will be higher in the sky at that time, so it may be that the solar gains are reduced enough that we don't overheat in that room. But it might. I'm also open to the idea that I might have to shade that room on it, and everything else is fine.
Thank you.
Thank you very much. Awesome. Okay, next up we have Paul Carr with a big question.
Hi, thanks for the presentation. You'd mentioned in the video, if for retrofit versus just a demo and rebuild was the right choice. You still feel that way? And is it a cost-effective approach for the general public? I mean, you're an architect and you had a lot of hands-on. Could the general homeowner do what you did, do you think?
So I'm not an architect, but I'm also was a beginner at DIY. Like the most ambitious thing I'd done in DIY, this isn't an exaggeration, was unblocking a sink before I did this project. So in terms of skill, in terms of practical skills, I was pretty lacking. I did the Passivhaus tradesperson course as a kind of thing to do for this course. But basic that doesn't teach basic DIY skills. It teaches you how to tape things properly and how to put insulation in properly. So in terms of basic DIY skills, I was very lacking. Was it cost effective? It was very expensive. We now have a lovely place to live in a place we want to live. So I'm looking at it. I'm pretty sure it's cheaper than knocking it down and rebuilding, just because we built less and we knocked stuff down and we knocked less stuff down. So on that basis, we didn't have to build new foundations. And I'm pretty sure. It's cheaper than it was cheaper than the typical cost for building a new house here. So yes, it might. What would have probably been more cost effective would have been to buy a piece of land and build a new passive house, but that would have been somewhere that was not as nice to live. That's the trade-off. Like there aren't bits of land available around this part. To buy a new land around here, you pretty much commit yourself to a very car-dependent lifestyle, because you're 10 miles from school, you're 10 miles from all the clubs that your kids want to do, you're 10 miles from any train stations. It's this location is quite special as far as I'm concerned, in terms of it's the ability to live here and not be ferrying kids around all the time. And that's partly a my quality of life thing, but it's also a quality of life for my kids thing. Like it's nice for them to gain their independence kind of organically, rather than me ferrying them around until they're old enough to drive themselves. That's like my son's 11 and he cycles to the climbing wall that's 3 miles away and cycles home on his own. And if we were living any of the places that we could buy somewhere that we could buy land, that wouldn't be an option.
Thank you.
Thank you, Paul. All right, next up we have Graham Williamson.
Hey, Es, thanks for that. It's more of a sort of technical question, but you mentioned that the solum in your house was pretty dry. The void underneath was was dry. I'm in a situation where my house is the opposite. It's quite damp under the floor. Would you have detailed the floor differently had that been your situation, or would you just have ventilated it more fully?
I think it would depend on trying to work out what the dampness was coming from. So I don't want to give advice about something so critical over here.
From the ground itself.
It's coming from the ground itself, right?
Yeah.
So I think if I would maybe look to improve the drainage so that it wasn't getting damp under there. But I think that there are solid floor options that I ruled out for my house that maybe I shouldn't have ruled out, that I would look into if I was doing it again, I think. Yeah. Okay. So like things like just filling the solum with glass, what's it called? Foam glass aggregate.
Glass,
but
we've got a much bigger crawl space, so
you have, right? Okay,
unviable. But
that's a lot of foam glass. Yeah. I haven't quite got my head around whether you need to have a path for the moisture to get out at all, or it's like it's a list on things. I've got a list of things that I would need to consider before taking on a project like this and advising. But yeah, I think I would investigate further whether there was a solid floor option that was viable.
Okay, thank you.
Thank you. Next up, we have Evangelia. Sorry, I think I mispronounced that. If you're available, please come on and ask your question.
Yeah, thanks for that. Evangelia Mitiaku. So, because you mentioned you prefer the retrofit rather than building a new one due to carbon reduction as well as anything else. So do you have an estimate of how much of the original structure and materials were kept, roughly?
Yeah, about half. About half of it. Like
so 50%
basically the whole
was kept.
Yeah, the whole ground floor, all the foundations, the ground, and in terms of embodied carbon, new foundations in a timber frame house is going to be where the bulk of your carbon emissions, your new embodied carbon emissions would come from. So if you can reuse the foundations, that's a big win to start with. So all the foundations, the ground floor structure was reused. The ground floor walls were reused. The ground floor ceiling joists were reused. So the only things that were new in terms of the structure were the kind of platform to hold the first floor walls, and the roof. So yeah, at least 50%, I would say. But I haven't actually done that calculation. But yeah, a pretty big amount of it.
If I'm allowed, I have 2 more questions. So Kim, is it okay? Shall I carry on?
Yeah, go ahead. That's fine.
A similar question for the floor. What was the strategy for the perimeter? And is the floor at any point still ventilated?
Yeah, it's still ventilated, and I actually added more ventilation, but it's all outside the wind tight. So there's now an airtight layer, a load of insulation, a wind tight layer, and then that space underneath the wind tight layer, I'm trying to ventilate as well as possible. Yeah.
And what about the perimeter where the timber joists meet either, I don't know, is it a timber structure that they meet
they meet a timber structure, yeah. So it's not
block work.
It's not block work, no, it's meeting a timber structure.
Okay.
So it's not got the problem that you have in where you have a suspended floor in a masonry build and the ends of your joists get cold and damp. It's not got that problem. So I wasn't worried about I saw someone else had asked about why I insulated internally rather than externally. I dismissed the possibility of doing it externally because I was worried about what would happen to any moisture that was in the walls or would get into the walls that needed to escape. And you'd need to fill the cavity, and then you need to insulate on top of that, like on the outside of the block work. But that would be a possibility, I think. I think with a bit of thought, you could probably make it work. It'd be much harder to DIY, I think. I think what I did.
And my final one is, do you have the result of the airtightness test?
Yeah, we got 0.46. air changes per hour at 50 pascals.
Well done. Thanks a lot
yeah,
for answering my questions.
Great, thank you so much.
And it was before works air tightness was about 16. So
wow,
we didn't get a proper,
no doubt for
proper
that.
number, but it was about 16.
Awesome, great questions. Thank you very much. Well, we are at the top of the hour, so I'm just going to hand it back over to our host to say some final words, and then we will continue on with a few questions that we have left. So if you had a last minute question, feel free to drop it in the chat and we'll see if we can fit it in, but I will start off handing it over to Mike.
Thanks, Kim. And thanks to Ez and everybody else. It looks like there's still a few more questions to go. So I'll shut up now. Thanks, everybody.
And I'll just say a big thank you as well for Ez for doing that. 2 points really. One on upskilling, that it's an amazing upskilling journey that he's done, and I feel like I was at the starting point. I'm still there and inspired by what he's done, because you can get complacent with learning, can't you? But then if you put yourself in this extreme learning, that's when you move on. And I imagine this must have fed back into your work at John Gilbert Architects a lot. So that's all good. So yeah, thank you very much. Hugh?
Yeah, Ez, amazing result on the air tightness. I meant to ask, so that's incredible. And without a pre-test, yeah, amazing. So quite
yeah,
the
it makes me wonder, like, if we'd done a pre-test and found all those few little leaks, whether we would have got even better.
the perfectionist in you.
Yeah.
Yeah.
Well, but
no,
interestingly, I think it is interesting. Like we didn't need to get 0.46, and we did work very hard. The difficulty with air tightness is you can't really say, oh, don't bother doing that bit, because you can get away with not doing that. It's really hard to say that. You've got to kind of aim for 0 and then know that you're not going to quite get to 0. It's tricky. There are a lot of air tightness things I would do differently, but we got a good result.
Yeah, well done. Yeah, thanks, Emma. So I guess back to you, Kim.
Great, thank you, Hugh. Next up, we have a question from John Darley. It looks like you're still here. Are you able to come off mute and ask your question?
Hello.
Yeah, go ahead.
Hi, John.
Thanks. Hi. Great project, guys. Thanks, Sharon. In terms of the floor, you've kind of hinted at it, but would you consider doing a natural solid floor, for example, lacquer or cork and earth on top of that, or would you consider just doing the timber floor in a different way?
So my understanding from my structural engineer was that I needed to keep the racking strength of having the floor joists with floorboards or chipboard on top of them. And so as I understood it, I needed to keep those joists. And so I think that would rule out doing like an earth floor. But in terms of, if it would work, then sure. But assuming that I have to keep those joists, I think I would investigate other ways of keeping those joists than what I did. Or doing what I did, but with a better way of getting insulation under the joists than the way I did it, because it was a lot of work.
Great, John, does that answer your question? All good?
Yes, thanks.
Okay, perfect. Next we have Andy Hall. I think that you mentioned this partially, but I'll let him come on and see if he has any additional questions.
I saw something saying he'd just left, but I saw it, so I can. He said, you mentioned that even if doing a lot of DIY, you still need expert input for a few tasks. I think the issue there was things that I found on site that we kind of realized, oh, the way we had intended to do this won't work because there's a serious moisture risk, or there's a serious thermal bridging risk, or it doesn't look how we thought it would look. And the key one that I remember was the junction for the floorboards, putting the floorboards in and having the wood fiber board in the walls. The way that we'd drawn it was that the floorboards would go back in the same place as they had done, then the wood fiber board would come down, and then you'd have a situation where the air tightness layer kind of went in this circuitous route, And because it was on the cold side, it went to a very cold place. And when you modeled it, there would be a moisture risk to the end of your floorboards. So you'd end up potentially getting the ends of your floorboards rotting. That was just one memorable bit, but there were quite often you come across something that's different from what you were expecting or different from what's in a book. And you have to think about how you're going to do it. And I think doing that without the input of someone who has a very good understanding of hygrothermal performance in buildings and thermal bridging would be really risky. I think there's big scope for doing it with a DIY method, but a lot of the DIY stuff that you see, people are making mistakes that make you wince. Well, that's how I experience it anyway. And I think because everyone has a house or everyone has somewhere that they live, everyone, it's common for people, like, I don't know, I'll speak to someone at the school gates and I'll say I'm doing this, and I say, and they'll say, I insulated my loft or my walls recently, and then you know that you're in for a conversation where you just have to keep a neutral face because they'll tell you how you did it and you'll be wincing. So I think people I think people doing this kind of deep retrofit without either doing a massive amount of upskilling of their own knowledge in terms of building physics is really risky. And I think the way around that is to have a combination of expert input and DIY doing the stuff. I think there's big scope for that Dunning-Kruger thing where you think you understand more than you do, and that's very dangerous.
Wonderful.
So that was Andy's question.
That seems like a very good place to start to wrap up here. We had one last question come in. It looks like David Rimmer has left. I think you answered this partially, but he was asking about making your house smaller internally at the ground floor and just impacts of, I think, living in. Yeah,
so we lost 100 mil on all the external walls, but we actually overall gained space on the ground floor because there was a bit of rearranging of space on the ground floor, and we lost a wood burning stove, which was taking up lots of space. And we had one wall that wasn't insulated, but had like 200 mil of fake stone cladding internally. And so we took that off. So we won space there. So overall it's bigger on the ground floor, but that's not what usually happens when you insulate internally. We had a funny porch that like nicked into the house, and for no apparent reason. And we made the external door flush with the main walls rather than kind of nicking into the house, and that gained us quite a lot of space. So actually we gained space on the ground floor as well as upstairs.
Wonderful. All right, I think that is it for questions. I'd like to just take a quick moment to thank you, Mike, Hugh, and Ben for hosting today. And Ez, thank you so much for this great presentation. I have put the link to the recording in the chat for folks. If you'd like to share it with your networks, please do, and we'll have that up in the next couple of days. But Ez, do you have any closing words or any advice for folks that are inspired?
Thanks very much. I guess the advice is like, get yourself committed, and then you don't have any choice but to do a good job. Like if you take your roof off, then you've got to finish the job then, haven't you? So yeah, good luck and enjoy it.